Alright, so in my last video, I called the factorial function with an input of 3, which that 3 is right here. And before I go further, I wanted to compare to what I have on my whiteboard in front of me with what is shown in the lecture. So I happen to have slide 58 printed out in front of me. And on this slide, we can see a few things. We can see the instructions, which are pretty similar to what I have right here. We have a box around call factorial 1, which means that we just executed that line of code. And here we can see the global stack, and we can see a 3, and that 3 corresponds to this 3. The main means that it comes from the main function, and that's not really something I want to explain right now. It might not make sense, but just don't worry about it too much. We have this other block right here called saved main frame, and that refers to these 5 cards that we just pushed onto the stack when we were calling Main.factorial. So these cards, 5 cards collectively, which I have written with a blue marker because in the VM emulator it'll show up as blue. But those 5 cards can collectively be referred to as a frame. And every time we call a function, we save some information about the previous function. And so that's why it's called saved main frame, because the information we have here happens to relate to our main function, or our function which is called Main.main. And this is what is referred to as the caller-callee relationship in the lectures, and it's not something I want to go into too much right now because it won't make sense until we get to function returning in a little while. But those are things I wanted to mention. And one last thing is that right here we have argument 0, and that's kind of very similar to what I have with this argument arrow right here, pointing out that this is a 0 with argument. And to give a little more context to that is that with other functions, we could have more arguments. In this case, we only have 1. But if we had multiple arguments, we'd have an argument 0, we'd have an argument 1, argument 2, argument 3, and argument so on for as many as we wanted. But this arrow is always going to point to the 0th argument. Unfortunately, this isn't the best example to show that because we only have 1 argument variable. If we had a function with multiple argument variables, that would be a little bit clearer, but those are just things I wanted to mention for now. And now we can get back to continuing with our function. So right now we're at line 4. And so the first instruction, well, we haven't actually executed line 4 yet. So why don't we actually look at that from the slideshow. So I have slide 123 printed out. And we can see here in this box that there are a few assembly code instructions where we would basically push a bunch of zeros onto the stack if we had local variables. But with this example, we don't have any local variables, so we don't push anything onto the stack. But if we did have local variables with this function, we would push a bunch of zeros onto the stack that come right after the frame. And a way how to think of this is that in some programming languages, not all programming languages, but some, is that when we define local variables, is that first we define them and then we populate them. And those are 2 separate steps. So in here with the VM emulator is that we push a bunch of zeros onto the stack, and that kind of reserves a spot for us to later go and populate those local variables with actual values that are relevant to our function. And so that's kind of what that means. But again, this isn't a perfect example for that, to show that because we don't have any local variables, but that's all I wanted to say about that.